my memory. Multiplying fractions. Without a calculator. How do we multiply fractions without a calculator?
I just have to figure out what that looks like.
I get it. What's up, TV? No. That's if we're adding and subtracting. No.
Oh, just multiply across then?
Multiply across. That's how we do. That's how we do. We
I thought it was that easy.
multiply across. Straight across. Okay? So this becomes 2 over 18. And then what do we do? Simplify. So that gives us 1/9. What if I don't like doing it that way? What can I do? What if I don't like multiplying first? Could I simplify first? Because 2 divided by 2, right, leaves me with 1/9. Okay? So these steps can be reversed. We could simplify first and then multiply straight across. As long as when you simplify, you're simplifying one out of the top and one out of the bottom. Okay? You can't cross out two things on the same side. Okay? One's got to be on top, one's got to be on the bottom. Can't be two tops or two bottoms. Okay? Dividing. What's the rule with dividing fractions? No, that's only with adding and subtracting.
Well, I don't know anything.
What's the rule with dividing? I know, we're making you think back to 4th grade.
Is it probably cross multiply?
Nope.
Darn.
You only cross multiply if there's an equal sign in between two fractions. Dividing fractions. Nobody? What you got, Kevin?
Times by the reciprocal.
So flip the second one first, right?
Yeah.
So we flip anything that comes after a divide sign, and then we do what? Flip and no. Flip and multiply. So this becomes 4 over 7 times 5 over 14. Two goes into 4 twice. 2 goes into 14 7 times. That leaves me with 10 over 49. Guess what? If you give me a decimal, I give you no points. You know why? Because you did it on a calculator. Okay? You give me a decimal, I give you no points. Answers for this entire section, along with the last section, this entire chapter, should be in fraction form. Okay? Unless it's a word problem. If it's a word problem, then we can have it in decimal form, but we're not dealing with word problems just yet. That's next week. Okay? Number 3. What's going on there? We simplify anything? No, because the top needs to be factored all completely, right? Okay, and there's nothing that can factor out of that entire top. So that's done. Okay, so that's my answer.
Can't you factor out a -1?
You could. You could if you wanted to. I would also accept here x plus 5 over 5x if you factored out a -1 from the top and the bottom. Yep, I would accept that too. Okay, but then what are the restrictions?
X cannot equal 0.
X cannot equal 0. Okay. Over here, anything simplify in number 4? Nope, nothing simplifies. Did you factor out a -1 in this one too? Okay. If you did, it would just be in your parentheses. It would be x plus, or no, excuse me, x minus 2, and your bottom one would be x minus 4. Okay. But then the 6 would still say positive. The x would still say positive. Okay. So what are my restrictions?
X can equal 4 and X can equal 0.
Would you be offended if I wrote it as x can equal 0 and x can equal 4?
Would not be.
Do you know why I do it that way?
Numerical order.
Yep. Numerical order. That's the only reason I do it that way. Okay. Good. Now, if you'll notice on the back side of your warm-up sheet, there are some extra credit problems. Okay. All right. So, because we have notes to do too, I want you to put your warm-up sheets away at this point in time because I don't want you working on those because you're not ready for those yet. Okay? And at the end of the day, you'll be ready for them. In 20 minutes, you'll be ready for them. Okay? But right now, not so much. Okay? Actually, you won't even because tomorrow's dividing. Today's only multiplying. So, all right. So, in your textbooks on page 614. Okay, there is a table, okay? And that table is comparing two different methods. Okay? There's method A, and in the first column, it just deals with numbers. Okay? And then in the second column, it deals with rational expressions. Okay? And then there's method B, again, with regular numbers and with rational expressions. Okay? My question to you is part A. Explain the difference between method A and method B. I'll give you a minute or two to peruse. Let it run a stitch. What are we noticing about the difference between the two? What do you got, Meg?
B simplifies first and A simplifies after. These all five.
So in A, we multiply across first, then simplify, right? And what did you say B did? They simplified first. Then they multiplied. Notice that they get the same answer in both cases. Okay? The answer here is 1/12. The answer there is 1/12. you're getting to the same spot. Okay? You've probably heard me say ad nauseum, there's many ways to get to Mosinee from here. Okay? Well, when we're multiplying fractions, there's two ways. You can either multiply first, then simplify, or reduce as we like to call it too. Okay? Or you can simplify first, then multiply. Now, part B of that question says, which one do you prefer? That's a you question. Okay? Because you're both, no matter what, if you choose method A and Stitch chooses method B, you guys are going to end up in the exact same spot. Okay? So that's a you. It doesn't matter. For me and for Kruger, both of us, doesn't matter. You're doing the math. It doesn't matter what order you're doing the math, but you're doing the math. Okay? Now, if you would have given us an answer here of, instead of 1 over 12, if you gave us 2 over 24, then we've got an issue. Because now we're not in the same spot. Okay? One's reduced all the way. One still can be divided both top and bottom by 2. Or 3 over 36. Or 4 over 48. Okay? Whatever. Okay? As long as you have reduced it all the way down, we will be in the exact same spot at the end. Okay? Alright? So, this is on page 615, number 4. Okay? Shaheen multiplies those two rational fractions without simplifying first. Okay? So he multiplied across. So he took here 5x squared and he multiplied it by 3x minus 15. So he distributed it in and he got 15x cubed minus 75x squared. That's true. That's a true statement. Okay? Then Shaheen multiplied 3x squared minus 75 by 4x squared and got 12x to the fourth minus 300x squared. Okay? Then Shaheen went to town on simplifying. He noticed that he could take a 15x squared out of the top, leaving him with x minus 5. He noticed he could take 3x squared out of the bottom, leaving him with 4x squared minus 10. Then he simplified. The 3 goes into the 5, or excuse me, the 3 goes into the 15 5 times, and these 2x squareds cancel, oops, I shouldn't use x. These 2x squareds cancel each other out. So he's left with 5 times the quantity x minus 5 on top, and then he factored a 4 out of this, factored a 4 out of there, and got that, then said, oh, this x squared minus 25 is a perfect square minus a perfect square. So he went to x minus 5, x plus 5 on that, then canceled out the x minus 5s, giving him that. Okay? Agree with all of that math. Okay? All that math is good. Okay? It's good. The answer here is 5 over x, or 4 times the quantity x plus 5. That is the true answer. Okay? You now do the exact same problem, except you're going to simplify first. So do all of your factoring in all 4 of your parts. Do all of your factoring. And then see if you get the exact same answer. Oops. Quick pause for the cause. Okay. Can you factor anything out of 5x squared? This numerator, actually let me go up here. This numerator up here. Can you factor anything out of that? No. Can't do anything with that one. Okay? So then you come down to here. Can you factor anything out of that one? Yes, what can you factor out? You can GCF out of 3, which I did in purple right there. Right? So you're left with x squared minus 25. What do you notice about x squared minus 25? That should be a x squared minus 25. What do you notice about it? What? Missing the D word at the beginning. The difference of perfect squares, right? So it factors to be x minus 5 and x plus 5, right? Okay, factor completely. Then you come up here. What can you do with that one?
Take out 3.
Take out a 3. Okay, what can you do down here? Oh, wrong one. What can you do down here? Nothing, right? Okay, so we're left with that. Now that we have that, now we run, if it's on the top and on the bottom, we can cross it out. So this 3 cancels out that 3 up there. This x minus 5 cancels out that x minus 5. Anything else? The x squareds cancel each other out. Okay. So what's left on top? 5. Actually. 5 is left on top. What's left on the bottom? And 4. So I'm going to write the 4 out in front. And now notice that we got the same thing that Shaheen got right there. Okay? Page 616, next page. Okay. A and B, dual. Spot check on the first one. Anything factor in any of the 4 parts? No. How can you tell that nothing's going to factor in any of the 4 parts? What is there not? If you look ahead in the fact that you can factor out of B, why do I know I don't have to worry about factoring in A? There's only one term. There's no plus or minus in any of the 4 parts. Top, top, bottom, bottom. Okay? All right, so now we can go right to simplifying. So, give me one that will simplify.
3b squared. You can take out 3ab.
So I could take out 3. Let's just do them individually. 3 goes into 3 once. 3 goes into 27 9 times. Okay, give me another one. The A cancels out the A. Okay, give me another one. The B does not cancel out the B. It takes 1 away, but it doesn't just straight cancel it. Okay, so the B there, but I'm left with a B on top. Okay, it doesn't just straight up take it away. What else?
You can do 2 and 4.
2 into 4. Leaves me with a 2 down there.
C's.
What about the C's?
Just one C on top.
There's one C left on top yet. Okay? So what's left over is BC over what?
I mean,
18.
except 36. I didn't get before.
Okay? Any restrictions? Oops, I should have put restrictions in there before I did.
No restriction.
Yes, there are restrictions. What are the restrictions?
X doesn't equal 0.
There is no X in this problem.
18 doesn't equal 0.
I already know that.
B or C cannot equal zero.
Just B and C? And A, because they're all in the bottom in my original problem, right? There's an A right there on the bottom. So A cannot equal 0. There's a B right there in the denominator. So B cannot equal 0. There's a C. I already used purple a lot. There's a C right there. So C cannot equal 0. Right from the start. Okay? So when should you be thinking about your restrictions? All the time. Yep, you think about it at the start of the problem, and you think about it all the way through the problem, and you think about it at the end of the problem. Okay? All the time you think about restrictions. Okay? Do I factor anything out of this one?
Yeah.
What? 5 out of the bottom on the left one, right? So this would become 5, and then I'm left with x minus 3. Correct? Factor anything else out. Stitch? Nope. Everything else is factored. Okay? So now we can start simplifying. What can we simplify? The x minus 3's factor each other, or I shouldn't say factor, simplify each other off. 3 goes into 9. The x right here takes out 1x there and left with that. Anything else? Okay, so what's left on top? 1. Okay, 1 is left on top. What's left on the bottom? 15x. What? She said she did it wrong. Okay, all right. What are my restrictions? X cannot equal 0. Oops. Is that it? What else, Taylor? And x cannot equal 3. Okay. Exit ticket today. You have just enough time. C is your exit ticket. Nope, I'll check it as you leave.
See,